Hi, welcome all. Am I audible, my dear students? मेरी आवाज आ रही है? Yes, very good. Uh, Before I actually start, let me tell you what courses I take on Unacademy Plus and how the courses are conducted. I take roughly 1 or 2 minutes. See, my dear students, my referral code is PK006. You can use this code. आप इस कोड को इस्तेमाल कर सकते हैं कि to avail 10% discount. You can take a subscription of 3 months or 6 months. It's up to you. तो मेरे subjects होंगे the subjects which I teach are thermodynamics, right? Then fluid mechanics. Then we have heat transfer. Then we have strength of materials, one of the important subjects. Then we have machine design. Okay. Then we have refrigeration, air conditioning, IC engines. Then power plant engineering, turbo machinery, or we call it as hydraulic machinery, right? So pehle मैं this is a special class. Just I'll give you a brief overview of what springs are, कहाँ पे हम springs use करते हैं और जो forces कैसे आते हैं और stresses कैसे generate होते हैं, ये सारे हम आपको बताएंगे, right? Now you can use my referral code, that is PK006. So I tried for 007 but नहीं मिला है 007. चलो कोई बात नहीं, चलिए. A request to all of you, so I'll be always on time. 1 or 2 minutes उधर इधर होगा, लेकिन I request all of you please be on time, because we have to be disciplined. Don't think that we are online so we can sit happily, comfortably. ऐसा पढ़ाई नहीं होगा. You have to be very serious, my dear students. The way you sit in class, जैसे क्लास में आप बैठते हैं वैसे ही अपना चेयर लेना, आराम से बैठना और सिंसियरली बिस्कुट खाते हुए ऐसा मत करना. जेन्युइनली हर एक सेकंड आपके लिए बहुत जरूरी है. ओके, अब हम आज देखेंगे today we'll see what exactly springs are. Excellent. So actually we can study this topic either in machine design or in strength of materials. थोड़ा बहुत basics आपको जानना बहुत जरूरी है, what is torsion, what is torsional shears, ये थोड़ा जानना बहुत जरूरी है. तो Akhilesh Patil ji, welcome. चलो, now let me define what exactly is spring. तो अपने आप को क्वेश्चन करना, ये स्प्रिंग होता क्या है? It is a machine element. I repeat, it is a machine element which is used to exert force. अभी लोग ज्वाइन होने में ही है, क्या हो रहा जी? Right. Let us take clutch. जब हम engage या disengage करते हैं तो engaging time में spring exerts force. Now let us take shock absorbers. उसमें क्या होता है? It absorbs shocks. So springs are used to exert force, like in clutches, or used to absorb energy. तो shock absorbers में क्या देखते हैं? It absorbs energy. Okay. Now today we'll discuss we'll discuss helical springs. Helical springs. Now, when I'm not writing on the screen, just look at me, look at my hands, look at my movements. I have a wire. I have a wire, a small diameter wire. अब इसको स्प्रिंग में कन्वर्ट करना है तो कैसे करेंगे? So I have a glass. तो ऐसा करेंगे. It's something like a cylinder, and the wire. This is the wire. देखो ये wire. This wire is wound. देखो, this wire is wound on this cylinder in the form of a helix, and you are getting a shape like this. You are getting a shape like this. So helical springs are something like, my dear students, helical springs are something like this. Yes. Now these helical springs, like on the cylinder, the wire is wound, and these cylinders, springs, helical springs, are of two types. One is closed coil, other one is open coil. Chalo. Now my dear students, what we do is, देखो एक बार इधर देखना. Now I'll draw a tangent to this. Excellent. This is, let the angle be alpha. अगर angle alpha is less than 10 degree, it is known as closed coil. If alpha is greater than 10 degree, this alpha, I'm talking about this alpha, this. If this alpha is greater than 10 degree, it is known as open coil helical spring. Very good. Okay. अब मैं बताता हूं. In closed coil helical spring, the space between these turns is very less. I think you might have seen cycle stand spring. It's something like this, my dear students. एक बार देखना. It's something like this. It's something like this. It's something like this. It's something like this. See the gap between the turns. उनके बीच में गैप क्या है? बहुत कम है. So a closed coil helical spring, as the gap between the turns, एक बार देखना, as the gap between turns is very small, already they are very close, so it cannot take compressive loads. So it takes only tensile loads because already the gap is small. एक बार इधर देखना. Closed coil helical springs. Closed coil helical springs कहां पे यूज करते हैं हम? Closed coil helical springs कहां पे यूज करते हैं? Cycle stands में यूज करते हैं. Now let us go to open coil helical springs. In open coil helical springs, the gap between turns is large. It's something like this, my dear students. देखो एक बार दोनों का गैप, टर्न्स में गैप देखना. आप टर्न्स में गैप देखना. I'll show you. My dear students, you just see the gap between the turns. अगर आप ये हम इसके अंदर डाल रहे हैं, एक एरो को डाल रहा हो, तो it can easily go inside. There is a gap. But if you see a closed coil helical spring, देखो एक बार, if you see the closed coil helical spring, the gap is already very small, so it cannot take what loads? Compressive loads. So as the gap is large, it can take tensile or compressive loads. Compressive भी ले सकता है ये, tensile भी ले सकता है. For example, ये जो open coil यूज करते हैं हम, ब्रेक्स में यूज करते हैं, क्लचेस में यूज करते हैं. अगर हम क्लोज्ड कॉइल की बात करते हैं, इफ आई टॉक अबाउट क्लोज्ड कॉइल हेलिकल स्प्रिंग, माय डियर स्टूडेंट्स, देखो एक बार, इफ आई टेक दिस क्लोज्ड कॉइल हेलिकल स्प्रिंग, द गैप इज ऑलरेडी क्लोज, सो दे टेक ओनली टेंसाइल लोड्स, और दे डू नॉट टेक, ऑलरेडी क्लोज है तो दे कैनॉट टेक कंप्रेसिव लोड्स. माय डियर स्टूडेंट्स, अरे नमूने, आर यू फॉलोइंग? अगर फॉलोइंग तो यस बोल देना. बोलो रे नमूने. वेरी गुड. हाँ, like this. Excellent. ये हुआ ना? Yes sir. Yes double S Y E S S S S ऐसा ना, मतलब इस पे ही मत बैठना इधर। अब जब मैं स्क्रीन पे काम नहीं कर रहा हूं तो मेरे तरफ और मेरे लाइक सी माय हैंड मूवमेंट्स। अब आप लोग सब यस सर बोलते ही जा रहे हैं, ये नहीं होना चाहिए। आप फोकस करो क्लास पे। I'll kill you. Just focus. So we have seen what exactly closed coil and open coil helical springs are. Now let us go for the design of helical springs. Now, my dear students, let's take the design of helical springs. Now, there is a spring. Yeah, आराम से। तो हम क्या पढ़ लिए? एक वायर जब सिलेंडर के ऊपर बाउंड करते हैं तो वो क्या होगा? हेलिकल स्प्रिंग होगा। उसमें दो तरीके के होते हैं। There are two types of helical springs. One is closed coil, other is open coil. And I have shown you clearly the difference between both. And you have already seen that closed coil helical springs are used in, like example diya hu, cycle stands, and open coil springs are used where? Excellent, like clutches, brakes, all those. Now have a look at this. Now let us take the axis. This is the axis, right? Now please, it's a request to all, join on time. Join on time, because we are absolutely on time. We are committed for your welfare. Now, right. Slowly I am learning how to draw on this. Right. Now, let us apply a load. Let us apply a load. 1 second, please. Let me apply the load. Just to see. This is the axial load. Yeah, we have applied. Now, if I apply axial load, helical spring subjected to axial load. Now, this is the helical spring and it is subjected to axial load. What do you mean by axial load? The load is acting along the axis of the spring. This is the axis. So observe here. This is the axis. And the load is acting along the axis. When a spring is subjected to axial load, now let us see to what type of stresses. Stress का मतलब है पेन इन द बॉडी। अगर आपके बॉडी में पेन ज्यादा होता है तो देयर इज अ चांस ऑफ फेलियर। सिमिलरली स्ट्रेस इज नथिंग बट पेन इन द मेंबर। ओके, नाउ व्हाट आई डू इज, माय डियर स्टूडेंट्स, let us take this. Now we have a load like this, right? Before we proceed, now let's see some of the important parameters. Yeah, look at. I'll use this. This is the outer diameter of the coil outer diameter. And if you take this, yeah, this is inner diameter. Now I use the word mean coil diameter. I use the word mean coil diameter. Let's see what is mean coil diameter. The mean coil diameter is nothing but outer diameter plus inner diameter by 2. Okay, this is our mean coil diameter, dm. We can also designate it with d. Now have a look at this. Let d be the wire diameter. What is d? Wire diameter. D is the wire diameter. D is wire dia. Right. There is one term that is spring index. I repeat, spring index. And that is given by the mean coil diameter d by wire diameter. Now, let's have a look at this. Here, the wire, this is the wire, this is the wire. The wire is of diameter d and the coil is of diameter capital D. Now, I have applied a load. Now, one second please. I have applied a load. What type of load I have applied? Axial load. Now, let's see, when I apply axial load, to what type of stresses are generated? Let us see. Now, I'll take an element of spring. Okay. Right. And if you take the mean diameter, this is the center. So this is our, actually, this total is mean diameter, dm or d. So this will be d by 2. This will be d by 2. Now, there is an axial load. Right. If there is an axial load, what I do is, my dear students, so the load is acting along the axis. So I'll put a load here. I'll add from simple mechanics. I'll add and subtract. That is two collinear forces W of magnitude W we have applied. Now let us see. Please understand carefully. If you take these two, so one is down, one is up. One is up, one is down. These two are resulting in torsion on this diameter, I'll show you, don't worry. And this is resulting in direct shear. Let's have a look at this. Let's have a look at this. Look at, my dear students. Look at, dekho ek baar. This is the spring. This is the spring. Now, understand carefully. So this load, I have applied W. Actually, I have applied a load W, and this I have applied W and W. So just from mechanics. So this is my W applied, and please observe here. This downward force is resulting in direct shear. This downward force is resulting in direct shear on the cross section of this wire, and this one. I repeat, this one, this downward and this upward, this downward and this upward is resulting in torsional shear. So I repeat, 1 second. Now have a look at this. This and this, it is resulting in a torsional shear of W into, the torque is W into D by 2. I repeat, एक बार फिर से देखना. So actually there is a load W. Now I am putting something like this. देखो एक बार, I'm putting something like this. Now, this downward, this upward is resulting in a torsion of this. It is resulting in torsion on the wire. This downward, एक second, this upward, this downward, it is resulting in torsion. It is resulting in torsion on the in the wire, like this, like this, like this. So there is a torsional stress. But these two we have combined in torsional shear, and we are left with one load, that is W. And it is acting directly on the cross section. So if W is acting directly on the cross section, if W is acting directly on the cross section, it will shear off. It will shear off. So there is a direct shear on the cross section, and there is a torsional shear on the cross section, and both are acting on cross section. So therefore, now I write direct shear. Direct shear. Let me designate it with tau1. Now observe here. Observe here. So what we are doing is this load. There is W here. There is W, and this W is directly resulting in shear, direct shear, like this on the cross section. So direct shear. So it is direct shear on the cross section, and then there is a torsional shear. There is a torsional shear. Both are acting on the cross section only. So now I write. So please observe here, because of this direct shear, which is acting on this, on the cross section. So therefore, direct shear, the load is W, and that is given by W by pi by 4d square, and that can be given as 4W by pi d square. This is the direct shear acting on the cross section. Now let's go for torsional shear. Now let's go for torsional shear, that is tau2. When we start strength of materials, in torsion chapter, I will be deriving one equation, T by J is equal to tau by R. Here, please understand carefully, when the couple is in the plane of cross section, it will be subjected to torsion. It will be subjected to, please observe, it will be subjected to torsion. So we have seen, my dear students, have a look at this. Now, okay, actually we have W. So I have, from mechanics, I have applied W and W like this. These two are resulting in torsional shear, and this is D by 2, this is D by 2, so it will be, torque will be W into D by 2. Excellent. Now, and that torsion is in the cross section. It is in the cross section. That torsion is in the cross section. Now, if you see these two are resulting in torsional shear, and this load, so there is a direct shear due to this. Both are on the cross section. So therefore, now we know that the wire is in torsion. We'll be seeing that the polar moment of inertia is given by pi by 32 d power 4, and the maximum shear is occurring at the outer fiber. So therefore, R will be, torsional shear I'm talking, R will be equal to D by 2. So now I write this secondary shear, torsional shear as tau2. Okay. Now, अब हम क्या करेंगे, tau2 को कैलकुलेट करेंगे. What is tau2? T R by J, and we know that T is WD by 2. Very good. R, what is R? Small d by 2, and J is pi by 32. That 32 will go to the top, d raised to 4. Okay, no problem at all. So therefore we have tau2 is equal to कितना हो रहा है ये, this 2 16, and this 2, this is 8. So therefore it will be 8 WD, and this D is gone. So therefore 8 WD by pi d cube. This is my secondary, this is my torsional shear. This is my torsional shear. Now, what we do is, observe here. Let's observe here. 1 second. Let's take a bigger view. See, the torsional shear is like this, that is WD by 2, and there is a direct load W. Please observe, this is the outer fiber and this is the inner fiber. Exactly. Now, please observe here. एक बार देखना, have a look at this. The torsional shear is in upward direction. It is in the upward direction. And see, when I apply like this, तो इधर का नीचे जा रहा है और इधर का ऊपर जा रहा है. So if you see, this side it is going down and this side is moving up. So therefore, if you see the torsional shear, on the outer fiber it is upward and on the inner fiber it is downward. And if you see the direct shear, due to W, and this is the torsional shear, and see, this is uniform throughout the cross section. The direct shear is uniform, and so at the outer fiber it is downward, and that is given by how much? Direct shear is given by 4W by pi d square, and here it is nothing but, just now we have calculated, so the tau 2 value is given by 8WD by pi d cube. Right. Now, if you see, my dear students, on the inner fiber, both are in the downward direction. If you see here, at the outer fiber, it is in the downward direction, it is in the upward direction. So therefore, the maximum shear stress is occurring. ये दोनों भी downward direction में है. So, but as both are acting on same cross section, so the maximum shear stress is occurring at the inner fiber, and that is given by that is tau 1 plus tau 2. But अगर आप आउटर फाइबर पर देखेंगे, एक अपवर्ड है और एक डाउनवर्ड है, सो दोनों माइनस हो जाएंगे तो कम हो जाएगा. सो अगर स्प्रिंग फेल हो रहा है तो वो इनर फाइबर पे फेल होगा, क्योंकि एट द इनर फाइबर द शियर स्ट्रेस इज मैक्सिमम, and that maximum is given by tau max is given by tau 1 is 4W by pi d square plus tau 2 is 8WD by pi d cube. Very good. So कहां पे फेल होगा? It will fail on the inner fiber, on the inner side. देखो, now let me try to show you clearly. If this is the diameter of the wire, if this is the diameter of the wire, अगर ये वायर का डायमीटर है, तो अब देखना जो डायरेक्ट शेयर है वो तो it is uniform throughout, so therefore it is same. So I read this as tau 1. लेकिन अगर आप torsional shear देखेंगे, in torsion will be discussing, इस पे the torsion shear is upward, okay, and इधर it is downward. So therefore these upward downward, तो ये downward है and this is upward, this is upward. तो अगर आप देखेंगे, this is the, एक second, this is the inner fiber, inner, and this is the outer fiber, outer fiber. Excellent. So therefore now if you see the inner, on the inner side, both are in the same direction, that is tau 1 and this is tau 2. So therefore please understand carefully, अगर helical spring जब वो axial load को सब्जेक्ट किया जाता है, it will fail. अगर फेलियर होता है तो वो inner fiber पे फेल होगा, क्योंकि inner fiber पे डायरेक्ट शेयर और टॉर्शनल शेयर दोनों का डायरेक्शन सेम होता है, as the direction is same on the inner fiber, but on the outer fiber the direction of direct shear and torsional shear, they are opposite. That's why the maximum shear stress occurs where? at the inner fiber. इसलिए अगर springs fail होते हैं, helical springs, when it is subjected to what I say, like axial load, so the failure will occur on the inner fiber because the maximum is there. So please understand carefully. अगर हम दोनों को add करेंगे, so tau max is equal to tau 1 plus tau 2. अभी हम already we have derived equations for tau 1. And what is tau 1, my dear students? 4w by pi d square, excellent, plus ये कितना था 8wd by pi d cube, excellent. I repeat, my dear students, I repeat, वायर जो होता है ना, अगर हम एक्शियल लोड सब्जेक्ट, अब if it is subject to axial load, the wire is subjected to torsion. तो देखना एक बार, टॉर्शन तो इनर साइड पे नीचे आ रहा है, आउटर साइड पे ऊपर आ रहा है, और देयर इज अ डायरेक्ट लोड. सो डायरेक्ट लोड तो नीचे है, तो अगर आप इनर फाइबर को देखेंगे तो टॉर्शनल शियर इज डाउन and direct shear is down, so therefore the failure will occur at the inner fiber. इसको थोड़ा हम simplify करेंगे. Let me simplify this further. So what do I get? So my dear students, 8wd by pi d cube, if I take, and this will take ये तो बाहर ले लिए तो 1 होगा, अगर इसको सिंप्लीफाई करेंगे तो क्या होगा, d by 2d होगा ये. सो एक्सलेंट. सो एक बार देखना, 8wd by pi d cube और ये dd गया तो 8 और 2 गया 4. यस, एक्सलेंट. सो the maximum shear stress is given by 8wd by pi d cube into 1 plus, already I have told you, capital D by small d is spring index C, and this is known as shear stress factor. This is known as what? Shear stress factor. And इसको हम लिख सकते हैं tau max is equal to ks into ये तो ks होगा 8wd by pi d cube. Excellent. And this is the equation for maximum shear stress. This is the equation for maximum shear stress. Very good. Now, please, and you know the failure is occurring on the inner fiber. No problem at all. My dear students, are you following? Are you following, my dear students? Very good. Excellent. Now, the problem here is, let me take a new slide. The problem here is, एक बार देखना, जब आप स्प्रिंग को देखेंगे, it is wound like this. My dear students, अगर आप, this is inner and this is outer. So if you see the length of the outer line, it is more than the length of the inner side. So as these lengths are different, we will be studying in the earlier classes of machine design. As this is the special class, just I am giving you the overview. When these two lengths are different, there will be stress concentration. There will be stress concentration. Matlab, due to the curvature, due to this curve, due to the curvature, there will be stress concentration. But जब हम derive किए equation को, क्या equation था मेरा? Tau max is equal to stress factor, shear stress factor 8wd by pi d cube. लेकिन इस equation में हम curvature, I repeat, curvature और stress concentration नहीं लिए. So if you have not taken, actually, due to this curvature and due to stress concentration, the stresses will be maximum. तो हम तो नहीं लिए. Therefore, Wall has conducted experiments and he gave the equation for the maximum shear stress as, instead of Ks, जब हम Ks लिखे थे, हम curvature और stress concentration नहीं लिए थे. So Wall has taken, and from his experiments, he introduced one factor known as Wall's factor, Kw. And now I replace that Ks, क्योंकि Ks, that is shear stress factor, उसमें क्या नहीं है? कर्वेचर इफेक्ट नहीं है और स्ट्रेस कॉन्सेंट्रेशन नहीं है. तो इफ यू इंक्लूड स्ट्रेस कॉन्सेंट्रेशन एंड कर्वेचर, द एक्चुअल मैक्सिमम स्ट्रेसेस विल बी मोर. दैट्स व्हाई for the safety in design you have to introduce curvature and stress concentration. So Wall has given the stress concentration factor as 4c minus 1, but this is from his experiments. 4c minus 4 plus 0.615 by c. So फर्क देखो, Ks और Kw. Ks, it will not take curvature, it will not take stress concentration into account. So Kw it takes. So मेरा actual equation होता है, my dear students, replace करो किसको? Ks को replace करो Kw, और बाकी का equation will be absolutely same. This is my equation. This is the equation for what? ये किसका equation है? मैक्सिमम शियर स्ट्रेस. और बताओ माय डियर स्टूडेंट्स, ये मैक्सिमम शियर स्ट्रेस कहां पे होता है? इनर फाइबर और आउटर फाइबर? अरे नमूने बोलो रे बाबा. इट विल अकर ऑन द इन. वेरी गुड कपिल पांडे जी, सही. अरे वाह, इनर इनर इन. वाह, मजा आ गया रे बाबा, मजा आ गया. वाह वाह, अब वाह बोलो. वेरी गुड, एक्सीलेंट. सो नाउ हैव अ लुक एट दिस. तो आपको कौन सा इक्वेशन लिखना है? वॉल्स फैक्टर लेते हुए करेक्ट इक्वेशन लिखना है. So my final equation will be, my dear students, my final equation will be the maximum shear stress. तो याद रखना, मैं आपको एक सवाल कर रहा हूं. The सवाल is, whenever the spring is subjected to axial load, to what type of stress? अगर एक स्प्रिंग को हम axial load अप्लाई किए तो वो कौन से टाइप ऑफ स्ट्रेसेस को सब्जेक्ट होगा? बोलो. It will be direct shear. आगे देखो. वाह, वेरी गुड. टॉर्शनल, वेरी गुड. अरे यार क्या है, ओनली डायरेक्ट बोल रहे हैं, रॉन्ग है. इट इज डायरेक्ट एंड टॉर्शनल शियर. अरे नमूने, आर यू गेटिंग? एक्सीलेंट, वेरी गुड, वेरी. अरे सम आर राइटिंग ओनली टॉर्शनल. नहीं, गलत गलत. इट इज डायरेक्ट एंड टॉर्शनल. बट देखो एक बार, दोनों भी कहां पे एक्ट कर रहे हैं? क्रॉस सेक्शन पे एक्ट कर रहे हैं. एक्सीलेंट. तो मेरा इक्वेशन बन जाएगा Kw8Wd by d cube. Excellent. This is the equation for maximum shear stress. Now, can anyone tell what does Kw take into account? Kw takes into account, anyone? बोलो. अब Kw का पूछ रहा हूं. Kw takes into account of what? किसका लेगा वो? Excellent. Curvature and stress concentration. Excellent. Curvature. Curvature and stress concentration. Very good, excellent. Now have a look at this, my dear students. All of you, are you following? Okay, are you following? Yes or no? Yes. Yes बोल के, why? Yes, time waste मत करना. Why बोल के लगना. Why? Very good, awesome, awesome, very good. चलिए अब देखते हैं. Now have a look at this. We have seen that when a spring is subjected to this, it is subjected to. Now, मैं आपको बहुत इंपॉर्टेंट चीज बताऊंगा. The important चीज is deflection of spring under axial load. Awesome. एक बात बताओ बेटे. I think most of you remember delta is equal to 8W_d cube n by gd power 4. How many of you remember? बोलो yes. भाई पूछ रहा हूं आपको, how many of you remember? Yes, yes. अब मैं सवाल कर रहा हूं. The most important thing is there is a difference between remembering by hearting and conceptual learning. अब मुझे बताओ, ये इक्वेशन के लिए assumptions क्या है? क्या कोई बता सकते हैं? Assumptions. I'm not asking Jason, Castigliano's theorem. मैं कौन सा थ्योरम यूज कर रहे ये नहीं बताया. ये इक्वेशन डिराइव करने के लिए assumptions क्या है? हाँ, good. No bending. Okay, okay, okay. और जो चाहिए वो. अरे यार ये इस पे थोड़ा कमेंट्स नहीं आ रहे. चलो मैं आपको बताता हूँ. एक सेकेंड. अब मैं बताता हूँ. Keep. Don't. No. अब कमेंट्स मत करना प्लीज. कमेंट्स मत करना, स्टॉप करो कृपया प्लीज. रिक्वेस्ट टू ऑल माय स्टूडेंट्स. अब ध्यान दो इधर. अब ध्यान दो. Now I want, please now it's a humble request to all of you, थोड़ा मेरे तरफ देखना. Humble request to all of you. Excellent. I am very happy with you, my dear students. आप you are really I appreciate you people. मतलब बहुत ही सही. No comments मतलब no comments कर रहा है और ध्यान दे रहा है. Excellent. Love you. Don't write love you. Again, keep quiet. देखो, when you apply a load, definitely, my dear students, due to this load, there will be a deflection, vertical deflection. Now, I wish to calculate the deflection of the spring under the load. देखिए, my dear students, थोड़ा मेरे तरफ देखना. Here we have a deflection. Here we have a load. I am applying this load. ये जो load है, I am applying gradually. What do we mean by gradually? धीरे से, slowly, from 0 to W, that is maximum, slowly. मतलब देखो, I have applied, this is 0, no load, no deflection. जरा सा load increase किए तो थोड़ा बहुत deflection आ गया, इधर आ गया, load बढ़ गया, थोड़ा देर रुको, फिर load apply करो. So when you are applying load, it is increasing, and keep quiet for some time. Apply, keep quiet, apply. So my dear students, if you are joining this, you will get something like this. This is my gradually applied load. So my dear students, ये load देखना और deflection देखना, both are in the same direction. So इसका मतलब है there is some work done in causing that deflection. देखो एक बार, ये load और deflection दोनों same direction में है, means there is work done in deflecting, and that, मान लो ये होगा अब maximum W और ये होगा आपका डेल्टा. Very good. So अगर आपको work चाहिए, that work will be given by, my dear students, this area. So work done is given by half W. Area of a triangle is half W delta. When a load is applied, when the axial load is applied, there is a deflection. Means when you are applying a load, the load and deflection are in the same direction. So therefore, जब load and deflection are in the same direction, there is some work done. And that work, as the load is gradually applied, slowly from 0 to maximum, that is W, 0 to W, the average load is W by 2, you can assume. So half W delta. Excellent. अब मेरा सवाल है, आप तो काम किए, मतलब जब लोड अप्लाई किए, स्ट्रेच हो गया, तो कुछ वर्क हुआ. अब ये वर्क कहाँ गया? ध्यान से सुनो. अब ये वर्क कहाँ गया? देखिए, प्लीज ऑल ऑफ यू ऑब्जर्व. आई हैव अप्लाइड अ लोड. देखो मेरे तरफ, आई हैव अप्लाइड अ लोड. देखो, व्हेन आई अप्लाइड अ लोड, या व्हेन आई अप्लाइड अ लोड, क्या हुआ? स्ट्रेच हुआ. लोड रिलीज करो. ओ माय गॉड, जब लोड रिलीज किए, वो अपने आप अपने पोजीशन पे गया. माय डियर स्टूडेंट्स, अपने पोजीशन पे इसलिए गया क्योंकि जो आप वर्क किए थे वो अंदर स्टोर किया था. अगर वो स्टोर नहीं करता है तो वापस नहीं आएगा. तो ध्यान से सुनो. सो देयरफॉर नाउ एब्सोल्युटली एक्सीलेंट इलास्टिक एनर्जी स्टोर. वाह. ओके, नाउ जब हम अप्लाई किए, प्लीज रुको एक सेकंड, आप कमेंट्स मत करना थोड़ा, प्लीज इट्स अ रिक्वेस्ट. I'll ask you so many questions, don't worry, I'll have very good interaction with you. थोड़ा ध्यान दो. So वर्क हुआ, कितना वर्क? देखो मैं लोड अप्लाई किया, जब लोड अप्लाई किया तो क्या हुआ? वर्क हो गया. कितना वर्क हुआ? हाफ W डेल्टा. अब वो वर्क कहाँ है? अंदर स्टोर हुआ, and we call that as strain energy. We call it as what? Strain energy. And that energy is stored in the spring in the form of strain energy. जब आप लोड को रिलीज किए, it will come back. So now I say, my dear students, work done. Please, no comments, please. Work done is equal to energy stored. Now देखो, there is a direct shear, there is a torsional shear. There is a direct load W, there is a torsional shear. तो स्ट्रेन एनर्जी इज स्टोर्ड ड्यू टू डायरेक्ट शियर। द स्ट्रेन एनर्जी, एक काम करो आप, सिर्फ एक इस पे केवल आप डायरेक्ट लोड अप्लाई करना, तो वो क्या होगा, एनर्जी एब्जॉर्ब करेगा। तो एनर्जी स्टोर्ड that will be due to direct shear. But if there is, apart from direct shear, if there is a torsion, so torsional strain energy is also stored. Means now I write this energy stored is equal to strain energy due to torsion plus strain energy due to direct shear. Please, I love you all my students because you are absolutely following the, like whenever I take offline classes, when I say when I tell my students not to write, they are for absolutely they follow, they don't write. You are also doing the same thing. प्रणाम all of you, thank you. अरे फिर संपत मैं मार डालूंगा आपको, लव यू टू क्यों लिखे है पहले आप सुनो, सॉरी माफ करना. Now have a look at this, my dear students, have a look at this. So now what I do is work done, no comments please, work done. Akhilesh ji, work done is equal to strain energy due to torsion plus strain energy due to direct shear. Awesome. My dear students, अभी तक इतने कमेंट्स आए, क्या कमेंट्स आए कि लाइक नो बेंडिंग, इलास्टिक, होमोजीनियस, ये सब बोले. अब देखना, द प्राइमरी assumption in deriving this is there is energy stored due to torsion and direct shear, but this energy stored, it is observed that this energy stored is very small, बहुत कम होता है उसका कंट्रीब्यूशन टोटल स्ट्रेन एनर्जी में. सो देयरफॉर इसका नो कमेंट, दुर्गेश पांडे नो कमेंट. सो इसका बहुत कम होता है, देयरफॉर हम क्या करते हैं, अगर ये कम होता है तो इसको नेग्लेक्ट करते हैं. सो प्लीज नोट डाउन माय डियर स्टूडेंट्स, while deriving the equation for deflection, I have neglected the strain energy stored due to direct shear. ये बहुत important है. It can be asked in interviews or it can be asked in examination also. Now, जब मैं आपको सॉम पढ़ाऊंगा तो strain energy due to torsion, I will be deriving, मैं आपको इक्वेशन ऐसे नहीं दूंगा, I will be deriving as half t theta. What does it mean? एक बार देखना. So when you say, एक point है, अगर if you apply a torque, so this point may shift to this, so there may, the angle is theta. So due to this there is energy stored and it is gradually applied, so half t theta. This is the strain energy stored due to torsion. ये जब मैं सॉम पढ़ूंगा assumptions के साथ derive करूंगा. I will derive, I will not blindly give you equation. And I will be deriving in strength of materials from the theory of torsion, T by J is equal to G theta by L. My dear students, observe here. Oh my God, Pushpendra has joined. Good evening, Pushpendra ji. Right now, please observe. अरे यार अखिलेश जी बोल रहे कब से पढ़ाओगे, बताऊंगा रे बाबा, एक मिनट, लेट मी कंप्लीट द क्लास. आफ्टर द क्लास में सारी चीजें बताऊंगा. प्लीज कंसंट्रेशन, प्लीज डोंट डिस्ट्रैक्ट, डोंट लाइक डाइवर्ट द अटेंशन प्लीज. मैं आपको सब बताऊंगा क्या पढ़ाना है, कब पढ़ाना है. प्लीज, इट्स अ रिक्वेस्ट, फर्स्ट यू फोकस ऑन द सब्जेक्ट. जो चीज इंपॉर्टेंट है उस पर ध्यान देना. नाउ हैव अ लुक एट दिस, माय डियर स्टूडेंट्स. प्लीज अंडरस्टैंड केयरफुली. इफ यू सी द स्प्रिंग, actually if you take this part, this is ineffective turns बोलते हैं हम, and these are effective turns. Let me designate effective turns with n. Now let us see the difference between effective turns and ineffective turns. इसको बोलते हैं ineffective. What does it mean? These ineffective turns, जब आप लोड अप्लाई करते वो डिफ्लेक्शन में कंट्रीब्यूट नहीं करेगा. सो मे बी सपोर्ट्स के लिए या कहीं फिक्स करने के लिए यूज करते हैं वो. सो ये जो इनएफेक्टिव टर्न्स है ना, दे डोंट पार्टिसिपेट इन डिफ्लेक्शन. सो जब भी आप एनर्जी स्टोर्ड के लिए कैलकुलेट करेंगे, ऑलवेज यू शुड टेक इफेक्टिव टर्न्स, क्योंकि वही लोड ले रहा है, वही मतलब डिफ्लेक्शन ले रहा है. सो देयरफॉर नाउ length of the spring, my dear students, already you know coil diameter is, coil ka diameter, mean coil diameter is d. So as the mean coil diameter is d, तो एक कॉइल का एक टर्न का लेंथ कितना होता है, सरकमफरेंस और पेरीमीटर पाई डी. बट देयर आर n इफेक्टिव टर्न्स, तो टोटल स्प्रिंग का लेंथ कितना होगा, पाई डी तो क्या होगा, एक का होगा. अगर n इफेक्टिव टर्न्स है, सो टोटल लेंथ ऑफ द स्प्रिंग इज पाई डी n. Please note down that where n is effective turns and L is effective length. हम इसकी बात कर रहे हैं. I'm talking about this length, effective length. So इस equation में now what we do is, let's see theta. Let us take this equation. I'll use this equation and I'll be deriving this equation in sum. Theta will be equal to, what is theta? TL by GJ. Excellent. And already you know theta is TL by J. So strain energy due to torsion. Now what we do is, I'll take this equation. Okay. Now I'll take this equation. Now this one, इस equation को लेंगे. So strain energy is given by half T into theta. What is theta? अभी तो यहाँ बताया. This is theta. So TL by GJ. So strain energy due to torsion, which I'll be deriving in your sum as T square L by GJ. This is the strain energy. Now have a look at this, my dear students. Now let me take the new slide. So therefore, you know, work done is equal to strain energy stored. But the strain energy stored due to direct shear is neglected, very small. So directly torsional, it is already having T square L by 2GJ. So if you see the previous slide, we have, if you see, it is T square L by Kangajivo. Yeah, this is T square L by 2DGJ. एक second. Now T square L by 2GJ. So यहाँ पे T square L by 2GJ. Okay, T square L by 2GJ. Now observe here. So please have a look at this. Now this can be written as, already you know the torque is given by, मैं बता दिया था, already the torque is given by WD by 2. So therefore the torque is given by WD by 2, इसका whole square. Length is given by pi dn by 2g. G is shear modulus J. Please note down that wire diameter, wire is under torsion. So therefore it will be pi by 32, wire diameter power 4. So therefore work done is half W delta and the strain energy is given by, so what is strain energy? ये वाला T square L by, so therefore W square D square by 4, क्योंकि 2 square is 4, into pi dn by 2g pi d power 4 into 32. So therefore this two is gone. This is 4 and this is 8. Excellent. And एक सेकेंड, तो डेल्टा बच गया. सो डेल्टा इज इक्वल टू यहाँ पे ऊपर क्या है, 8 है. दिस इज 8. ये डब्ल्यू गया तो कुछ अलग कलर से, ये डब्ल्यू और ये डब्ल्यू गया, तो 8 बचा डब्ल्यू. डी स्क्वायर इंटू डी इज डी क्यूब, वेरी गुड, n. And we'll cancel this pi with this pi. So therefore 8w d cube n, 8w d cube n by g d power 4. Now my dear students, देखो यार इसमें क्या नेग्लेक्ट किए, the strain energy stored due to direct shear is neglected. There is one term known as spring stiffness. That is K, and that is given by, if I apply a load, under the load what is the deflection, that we call it as what? If I apply a load, axial load, there is a deflection. So what is the deflection? मान लो my dear students, अगर spring का deflection कम होता है तो it is stiffer. So therefore now if you take from this W by delta, if you take W by delta, it will be g d power 4 by 8 g d power 4 by 8 d cube n. Now have a look at this. He may be asking a question. So this is my k. So I can write k is, देखो एक बार, for a given configuration मेरे पास एक स्प्रिंग है, इधर देखना. अगर मैं इस स्प्रिंग को मैं डायमीटर वायर का डायमीटर चेंज नहीं कर रहा हूं, कॉइल का डायमीटर चेंज नहीं कर रहा हूं, अगर इसको मैं आधा काट डालूंगा, इफ आई कट इट इनटू टू पीसेस इक्वल हाफ्स, इक्वल, तो क्या होगा? लेंथ क्या होगा? आधा होगा. But L is equal to pi dn. We are not changing the diameter, so L is directly proportional to n. When length becomes half, n becomes half. So therefore, if you see from this equation, k is inversely proportional to n. So when you cut the spring into two parts, the stiffness will become double. All of you, are you following? I don't know, I'm teaching, but are you following, my dear students? Yes or no? Yeah. Wow, very good. So the deflection of the spring is given by, my dear students, the deflection of the spring is given by, so bolo ek baar, delta is equal to 8w d cube n by g d power 4. Excellent. Now this is the equation for what I say, axial deflection when the spring is subjected to axial load. And please note down that here the direct shear is neglected. Okay, now let us take a spring. There is one spring. Let us take, let its stiffness be K1. And let us take another spring. Let the stiffness of this spring be K2. These two springs are joined in series. When one end is connected to other end, we call it as series. Now let me apply a load W. Definitely, जब हम load apply किए, when we applied a load W, there will be deflection of first spring and there will be deflection of second spring. But let delta 1 be the deflection of first, delta 2 be the deflection of second. तो क्या हो रहा है? The total deflection is given by first spring is deflecting thoda, second spring is deflecting thoda. So total deflection will be delta 1 plus delta 2. So just now you saw k is equal to w by delta. So delta 1 will be equal to w by k1 because the same load is transmitted, and delta 2 is equal to w by k2. Now the total deflection is given by delta 1 plus delta 2. So therefore delta 1 is w by k1 and delta 2 is w by k2. Now I use one term, effective spring stiffness. हम क्या कर रहे हैं? ये पूरे कॉन्फ़िगरेशन को I'm converting it into a single equivalent one. अब दोनों को हम क्या करेंगे? I'll convert this into a single spring. Let the spring stiffness be equivalent be K. It is hypothetical. Okay. Now same load, it is subjected to same load. Now the question is, when can I call these two equivalent? ध्यान से सुनो. These two are equivalent only when the under the same load, when the deflection is same. तो load तो same होगा, तो यहाँ का deflection क्या होना चाहिए? The total deflection is delta. यहाँ पे it should also be delta. And you know K is equal to W by delta. So therefore now I write delta is equal to W by K. This is giving me delta and this is giving me delta. So equate both deltas. So therefore W by K, इसको हम बोलेंगे equivalent. So W by KE is equal to W by K1 plus W by K2. So therefore if I cancel out, you have W, we have equivalent stiffness is 1 by K1 plus 1 by K2. This is my equation for equivalent spring stiffness when they are in series. On similar grounds, we can derive the equation when they are in parallel. So in vibrations, like in damping, we use in parallel. Like for example, now to damp this, okay, let us say this is one and there is another spring. Okay, let the stiffness of this spring be K1 and the stiffness of this spring be K2, and we have applied a load W. Please note down that the same load W is not transmitted through both. Now the load is shared between both. Let the first one take a load of W1, second one take a load of W2. So therefore it will be W1 plus W2. But please mind, my dear students, so both are deflecting by same amount. Now I'll convert this into equivalent. For equivalent, what is the condition? The total load should be same, the total deflection should be same. Now let the deflection be delta. So this is delta. So you know K is equal to W by delta, or W is equal to K into delta. So now this W can be written as KE delta. So यहाँ पे KE delta आएगा. What is W1? W1 will be, इधर देखना, W1 will be K1 delta and W2 will be K2 delta. So therefore, let us remove delta. If I remove delta, we have equivalent spring stiffness when they are in parallel is K1 plus K2. Very good. Now let us overall let us discuss like what we have covered, and I'll take up some of the questions. Okay. Oh my God, it's already 1 hour. Okay. Shall I take for some more time? What do you say? What do you say, my dear students? Shall I take for some more time? Okay. Yeah. Yes. Okay. Chaliye. Now let us review what we have done. Ek second. And now noise suno. In 2 to 3 minutes, let us briefly recollect what we have done. When I started, 5 minutes, please. When I started, I said about helical springs. See, my dear students, if this angle is less than 10 degree, it is closed coil. In closed coil springs, I have shown this. For example, the gap between is very, very small. People who have joined late, they missed initial 10 minutes were very crucial. I've shown you the gap between them is very small. If you use this in cycle stands, so closed coil helical springs, the gap between them is small. So already it is closed, so it cannot take compressive loads. It takes only tensile loads. Now, if you take open coil helical spring, yeah, they can take both compressive and tensile loads. No issues at all. Next, then we have derived the equation for maximum shear. The maximum shear is given by Ks into 8WD by pi d cube. But this neglects the curvature effect and stress concentration. That's why I took Wall's factor, and that is Kw is 8WD by pi d cube. Very good, my dear students. And then I have derived the equation for the axial deflection as 8WD cube n by G d power 4, where n is effective number of turns. Mind you, effective number of turns. Okay. So अब मैं आपको क्या बताऊंगा कि like ठीक है, these are only basics. So my next class 16 तारीख को शार्प 8 बजे मैं आपको बहुत ही अच्छा कॉन्सेप्ट फ्लूइड मैकेनिक्स का कॉन्सेप्ट दैट इज वेपर प्रेशर और कैविटेशन बताऊंगा. वो स्पेशल क्लास होगा, वो फ्री होगा. और आगे मेरे क्लासेस को सुनना है तो यू कैन यूज माय कोड, that is referral code is PK006. PK stands for Praveen Kulkarni 006. This you can use for concession, 10% concession. So you can take a 3-month trial or 6-month trial. There is no issue at all. So the subjects which I take, which I have been teaching for the last 18 to 20 odd years, are thermodynamics, fluid mechanics, and I'll be giving you notes also. I'll be उदित नारायण साहब हेलिक्स एंगल पूछ रहे हैं, मैं ऑलरेडी बता चुका हूं, क्या करो सर, इट इज शोइंग रजिस्ट्रेशन इज क्लोज, क्या करें. नोट्स everything I'll share, I'll give you all notes. I'll be teaching fluid mechanics, thermodynamics, heat and mass transfer. Actually, it is heat transfer. In our syllabus, there is no mass transfer. Then we have strength of materials, machine design, RAC. Then we have power plant engineering, then turbo machinery. These are the things which I'll be teaching you. So, and someone asked me production. So yeah, in production, I'll be teaching only metal forming. Okay. Now, one of my students asked, what is the book for machine design? So, अगर आपको examination clear करना है, तो you take Bhandari. But actually, if you want concepts, and I suggest you Shigley or Norton. Okay? So, like from examination point of view, this is more than enough. Now, please observe, my dear students. These are the subjects that I'll be taking, and definitely you'll be enjoying. So I'll take up questions and everything, and see if most of the times I'll be trying to answer. But if you want my number also, I'll give you like 78931909007. So okay, fine. So 78931909007. You can give me leave a message. So, but most of the times I'll be answering online only through, like, we have a doubt session. On doubt session, I'll be giving you everything in a crystal clear manner. So actually, कैसे आ रहे stresses, ये बहुत important है, बहुत important है. So these are very important. So stress is actually internal pain. So if a member is subjected to a lot of pain, so मैं आपको जब fluid mechanics या strength of materials पढ़ाऊंगा, pressure और stress के बीच में क्या अंतर है, what is the basic difference? There are about 5 to 6 differences between pressure, though they have same units, there is a lot of difference between pressure and stress. ये सारे बताऊंगा. All these some students ask, like they ask, what are the textbooks to be followed for SOM? My dear students, when I come back for SOM, I'll be giving you all the things in detail. I have some live models when I take offline classes at Kulkarni's Academy of Mechanical Engineering, CAME. So in CAME, like I'll be taking only limited students, that is 30 students, as 300 students, not more than that. So I'll be taking offline classes only at Kulkarni's Academy of Mechanical Engineering, CAME. There I'll be giving you some live models also. What is the exact working, where on which plane it is bending. All those I'll be showing. Don't worry. Oh, Sampa Siddham, love you. Yeah. On 16th, I'll be coming for a beautiful concept, and you love it. I'll mix thermodynamics with fluid mechanics to show the beauty of cavitation and vapor pressure. So will be PK006. PKC. Please use my referral code. Please use, my dear students, referral code PK006 for further updates. And if you want to join, you can take 3 months course and 6 months course. It's up to you. So I repeat, PK not 6, not 6. You can use this, and definitely I'll try my level best to show you the beauty of each and every subject. So do not worry. So be happy. Love you all, and good night. Work hard. And one more request, my dear students. The request is when you are attending online classes, the problem with you is as you are at home or at some places happily, you relax like this. ऐसा नहीं होता है. You should be focused. And I'll be giving you notes on this in a detailed manner. Don't worry, everything is ready. So I'll be giving each and everything. Absolute notes will be given in English. My classes will be in Hindi and English. No one will face any problem. All sections I'll be taking care. So my dear students, goodbye, good night, Shabba Khair. All the best. God bless you. We'll be meeting soon on 16th for a beautiful concept, vapor pressure and cavitation. Love you all. Bye-bye. Good night.